All right, class, we're now moving into chapter 5, getting into thermochemistry, so kind of energy when we talk about chemical reactions. And I just wanted to note, thanks for your hard work in prepping for the chapter 1 through 4 tests. And if you felt that you didn't perform as well, try to meet with me, maybe one-on-one, and we can develop some strategies or think of ways to be more successful in the future. Okay, so chapter 5, thermochemistry. So when we talk about thermochemistry, we're really talking about the energy of a reaction. And energy, really in its fundamental form, is the amount of like work. And work is it's actually a physics term, but it's the ability to do something, to kind of cause some type of change. So there's work and heat. So energy used to cause an object that has mass to move is called work. So when you like lift up a book from the floor up to the table, that would be doing work on the book. So the book is moving from one location to another. So there's work being done on that object. And then energy is also used to cause the temperature of an object to rise. So that type of energy is referred to as heat. So these are we're kind of getting the basic terms of work and heat, and we'll apply them in a chemistry fashion. But keep in mind, these are actually fundamental physics terms that we then apply within a chemistry context. So one form of energy that we refer to is called potential energy, and I'm sure that you've been introduced to potential energy before in other classes, but it's the energy that an object possesses in relation to its position or its chemical composition. So chemical bonds have potential energy, and an object like at the top of a hill, the example being in this image of a biker. And once that biker moves or begins moving down the hill, the potential energy is turning into kinetic energy, and that is the energy associated with motion. And you have the basic formula for kinetic energy is equal to 1/2 mass times velocity squared. And it's the energy of motion. When you think of temperature, so when we measure temperature, we are measuring the average kinetic energy of a solution. So like yesterday's or this week's lab, you measured the temperature change of a variety of substances, and those temperature changes were related to how the average kinetic energy of those solutions was changing when chemicals were reacting. Okay, the units of energy that we use are the joule. Okay, and the joule is if we were to define a joule, it is kilograms meters squared all over seconds squared. And it's really important that you at least note those units, because like I've said before, sometimes when we are calculating an answer or trying to determine the answer of or the solution to a question, sometimes we might not know where to go to solve it, but if we start kind of looking at what units we're starting with or what units we can find or measure, we can lead ourselves towards the answer that we need to find. Another form of or unit of energy that has been used and you still find around a lot is the calorie, or abbreviated as CAL, and it's another way of measuring how energy changes. And you have this conversion relationship between joules and calories that we will probably utilize this year as well. So 1 calorie is equal to 4.184 joules. Another aspect of when we talk about energy, we need to be able to define what is the system and what is the surroundings. So it's very common in physics when we're trying to talk about a phenomenon to describe the system. So whether the system is doing work or the system is having work done on it, and then the surroundings. And really, the surroundings are everything else. So the system, especially in chemistry, would be like the reaction vessel or inside the beaker, or the thing that we're observing, and then the surroundings is everything else associated with it. Like I said, the surroundings, everything else. So in the example, in the image on the left, you've got a piston here, and we've got some hydrogen and oxygen molecules kind of bouncing around. And so within that chamber, we would refer to that as this system, and then everything else would be the surroundings. So even like that chamber pushing up on the piston would be, the piston itself would be the surroundings getting moved. So work, on the other hand, is the energy used to move an object some distance. And you have a formula here for work. So work is equal to force times the distance that the force is exerted. And we'll kind of apply it. I don't want to get into too much of the physics of it, because we really are more interested in how it applies to the chemistry rather than the physics piece. Okay, so heat. Now heat is a very common aspect of what we do in most reactions in chemistry. And like I said, your Tuesday lab was all about heat and how it's, how we notice a change in temperature when when we combine the hypochlorite with the unknown. Okay, so energy can also be transferred by heat, and heat is basically the movement, moves from warmer objects to cooler objects, and it doesn't naturally go the other way. So you don't normally have, like if you have a block that's at room temperature, it's not going to suddenly start getting really cold by, moving the heat away from the block with it. So they equalize. So let's say I have a hot brick. I put a brick in the oven. I don't know why I put that brick in the oven, but I put it in the oven, and then I take it out of the oven. I set it on a countertop. Okay, well, the brick is definitely going to be hotter than room temperature. So over time, the heat is going to transfer from the brick to the surroundings. So thus, the brick is going to cool down, and the room will technically heat up or gain more heat. Okay, so one thing to note is we do a lot of studying of the conversion of energy. When energy goes from one form to another, the example of the biker is that it goes from potential energy to kinetic energy, energy of motion. In chemistry, we do a lot of where we have chemical potential energy in the form of chemical bonds, and when a reaction occurs, chemical bonds are broken, new bonds are formed, and usually in that process we will get other forms of energy. We'll get heat energy given off, or we might even get light energy that's given off. So some different forms of energy that come out of conversions of energy. And I kind of already talked about that. So as this woman coasts down the hill, her potential energy is converted to kinetic energy, and her potential energy, once she reaches the bottom of the hill, her potential energy will be 0, because she can't go any further down into the ground, and then her kinetic energy would be at its maximum at the very bottom of the hill. Now obviously, when we start talking about friction and wind resistance, it becomes a more complex question, but these are the basics that we're talking about. And I do recommend studying physics as well, because these are fundamental concepts that you'll explore later on if you go on to pursue more science. And there we go. I kind of said all those stuff. All right, so that's it for today, and I will see you in class